So the next chapter and section of this unit is Chapter 1, Section 2, Finding Cube Roots. So that's what we're talking about today. It's a little different than square roots, and we'll get into that. A cube root of a number is a number that when multiplied by itself and then multiplied by itself again equals the given number. A perfect cube is a number that can be written as the cube of an integer. This little symbol right here is what we use to represent a cube root. It's a square root with a little 3. And that represents our cube root. So if I'm trying to find the cube root of, let's say, 27, I'm asking myself, what number times itself twice gives me 27? That number is 3. 3 times itself twice. 3 times 3 is 9. 9 times 3 is 27. So the cube root of 27 is 3. We're doing the reverse of cubing a number. If I had 3 cubed, it would want me to do 3 times 3 times 3, which gives me 27. So instead of going from 3 cubed to 27, I'm going from the cube root of 27 to 3 today. So you're asking yourself, what number times itself twice gives you the number under the radical? So let's jump into some examples. It just says find each cube root. Letter A is the cube root of 8. So I'm asking myself, what number times itself twice gives me 8? The answer would be 2. 2 times 2 is 4. 4 times 2 is 8. So I know the cube root of 8 is 2. Hopefully you guys have maybe seen this before, or if not, it is making sense. If not, you can always ask questions through Canvas or email me. Letter B, we want the cube root of negative 27. Now, square roots, in Algebra 1, we cannot take the square root of a negative number. We can, however, take the cube root of a negative number. Anytime you take the cube root of a negative number, your answer is going to be negative. So I'm asking myself, what number times itself twice gives me negative 27? That would be negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 gives me negative 27. So I know the cube root of negative 27 is negative 3. Letter C, we've got a fraction, but don't let that scare you. We can still handle it. For cube roots of fractions, we have a rule that says I can split it up into 2 different cube roots. I can put 1 under its own cube root and 64 under its own cube root. So now I'm just finding the cube root of 1 and the cube root of 64, and I'm putting them over each other. So the cube root of 1, just be 1. 1 times 1 times 1 gives me 1. Cube root of 64 would be 4. So that means that the cube root of 1 over 64 is 1/4. 1/4 times 1/4 would give me 1/16. 1/16 times 1/4 would give me 1/64. So I know the cube root of 1 over 64 is 1 over 4. And let's look at letter D. Cube root of 27 over 125. Once again, I can split it up into the cube root of 27 over cube root of 125. Cube root of 27, as we saw earlier, was 3. Cube root of 125 is 5. So the cube root of 27 over 125 is 3/5. Once again, I can check my answer. If I do 3/5 times 3/5, times 3/5, a number times itself twice. 3/5 times 3/5 is 9/25. 9/25 times 3/5 gives me 27 over 125. So I know 3/5 is my cube root. Let's move on to the next set of examples. Evaluating expressions that contain cube roots. So last week we talked about evaluating expressions. So this is the exact same thing. We're just throwing some cube roots in there. So we're just using our order of operations. So the first thing I need to do for my order of operations is my grouping symbols. The cube root is technically kind of like a grouping symbol in this case, so I have to evaluate the cube root first. We'll also see later on down the road that cube roots are technically exponents. So that'd be my next thing on my order of operations. So I'm taking the cube root of negative 216. I'm asking myself, what number times itself twice gives me negative 216? It is negative 6. So now I'm left with 2 times negative 6 minus 3. Multiplication and division comes next because I don't have any exponents to deal with anymore. So I'm doing 2 times negative 6, which gives me negative 12. Now all I have left is subtraction. Negative 12 minus 3 gives me negative 15. So just like we did last week, using our order of operations to evaluate expressions, we just have cube roots thrown in there. Let's look at letter B now. Some of you may be able to see this right off the bat. Some of you may not be able to. If I have a cube root raised to a third power, so a cube root cubed, like I have on letter B, the cube root and the cube just kind of cancel each other out. So I'm just left with what's under the radical. Let's see why that happens though. So let's just take the cube root of 125. What number times itself twice gives me 125? That would be 5. Now I have to do my exponent. 5 to the third gives me 125. So it just pretty much undoes the cube root. And then 125 plus 21 gives me 146. So there's my expression evaluated. It's the numerical value of that expression. So hopefully you're good with evaluating expressions. Now you just got cube roots thrown in there, so it should not be too bad. Next set of examples. Evaluating an algebraic expression. So what makes it algebraic is that I have variables in there and they give me a value for my variable. So the very first thing I need to do is plug in 192 for x, since x equals 192. So anywhere I see an x in my expression, I'm going to plug in 192. So I get 192 over 4 plus the cubed root of 192 over 3. So now I've plugged my x value in. Now I just need to evaluate my expression like I did on the previous slide. So I need to deal with my cubed root first. Now 2 slides ago we saw that we could break up a fraction and put the numerator under its own cube root as well as the denominator in its own cube root. If I do that here, if I take the cube root of 192, I do not get a nice whole number out of that. Same thing with 3. If I take the cube root of 3, I don't get a nice whole number. So I'm going to go ahead and divide 192 divided by 3 first, see what I get. So I still have 192 over 4 plus the cube root. 192 divided by 3 gives me 64. 64 is something that I can take the cube root of. Cube root of 64 would be 4. So now I need to do my division next. 192 divided by 4. And that gives me 48 plus 4. 48 plus 4 gives me 52. Excuse me. So the numerical value of my expression when x equals 192 is 52. Can't see that very well. 52. We just plugged in our x value and used our order of operations to work it down using our order of operations. So let's look at letter B. 9x plus the cube root of x. Once again, I just need to plug in 1 over 27 in for x because x equals 1 over 27. So I get 9 times 1 over 27 plus the cube root of 1 over 27. So luckily, 1 over 27 is something that I can take the cube root of. So I still have my 9 times 1 over 27. Breaking up my fraction, the numerator with its own cube root, the denominator with its own cube root. Cube root of 1 is 1. Cube root of 27 is 3. So the cube root of 1 over 27 is 1/3. So I've done my cube root. Now I can continue with the rest of my order of operations. So I'm going to do my multiplication first. 9 times 1 over 27 gives me 1/3. And now I just have my addition. Remember, if you're adding or subtracting fractions, you need a common denominator. Luckily, we have a common denominator right here. They both have a denominator of 3. So I can just add my numerators. 1 plus 1 gives me 2. Keep my denominator the same. So I get 2/3 for my answer evaluating my expression. Once again, just plug your x value in, work down using your order of operations. Here's our last example right here. Evaluate 5 times the cube root of 3x minus 9 minus 7x when x equals -6. Once again, plugging in -6 for x. So I get 5 times the cube root of 3 times -6 minus 9, it's all under the radical, minus 7 times -6. Minus 7 times -6 is not under the radical. So do not make the mistake of putting it over all of that. We have to look at the original problem and see what the radical is enclosing. So now, I just have to do my order of operations within the cube root. So I'm going to do 3 times -6 first, which gives me -18 minus 9 minus 7 times -6. And now I can do -18 minus 9 under the radical. -18 minus 9 gives me -27 minus 7 times -6. Now I can take my cube root because I just have one number under my radical. So 5 times the cube root of -27 would be -3 minus 7 times -6. Now I just do my multiplication and division from left to right. 5 times -3 gives me -15. -7 times -6 gives me 42. And now I just have the addition. -15 plus 42 gives me +27. So like I said, hopefully you guys are okay with cube roots and evaluating expressions. We're just kind of combining both of them today. So here's our assignment. Page 13, numbers 2 through 26 all. Yesterday for A group, I told them this would be due tomorrow, Thursday. But since I'm posting this so late, I'm actually going to push the due date back to Friday. So this will be due Friday. That would be October 23rd. That's the due date for everybody. Due Friday, October 23rd on Canvas. It's going to be a file upload. I'm going to open the assignment and make it a file upload. So you just do the work from your book on a piece of paper, take a picture of your piece of paper, and you can upload it to Canvas. If you have any questions about any of that, please let me know. You can message me through Canvas or shoot me an email. Hope y'all have a great day, and I'll see y'all later.